Okay, so what I'm going to do now is I'm going to turn my camera around so I can video what I'm doing for everybody. So everybody at home will be able to see what I'm doing too. All right. So you're going to continue completing the slides as I do the experiment. So what we're doing then is we want to investigate how the surface area can affect the rate of the reaction. Specifically, we're going to use Alka-Seltzer and water to do that. So I guess my question is, how does surface area affect the rate of the reaction between Alka-Seltzer and water? Okay, that's going to be the experiment. I'm going to do an experiment to test that, to answer that question. How does the surface area affect the reaction rate between Alka-Seltzer and water, or something along those lines? How does the surface area affect the rate of the reaction between Alka-Seltzer and water? Any questions about that? Okay. So then I just want you guys to talk to me about what you think. What do you think? How do you think the surface area, how do you think changing the surface area is going to affect the rate of the reaction? Remember we said when we cut it into little pieces, we're going to be increasing the surface area, all right? So when we cut it into smaller pieces and we increase the surface area, how do you think that's going to affect the reaction? You think it's going to make it go faster? You think it's going to make it go slower? What do you think?
Faster.
Think it's going to make it go faster? What about you, Bridget?
Faster.
Faster? Okay. So then that can be what we think. That's our prediction as to what we think the answer is going to be. When we cut the Alka-Seltzer into smaller pieces, we're going to increase the surface area, and we think that's going to make the reaction happen faster. Okay, so that's our prediction. Now, we'll do the experiment to see if that's correct or not. Okay? Any questions? All right. So I'm going to be testing 3 different surface areas, and so I'm going to need 3 different tablets. So I have a package of Alka-Seltzer tablets, so I'm going to go ahead and get those out, but there's only 2 in a package, and so I had to get another package. And again, these are the name brand, okay? These are the name brand Alka-Seltzers. There's also generic Alka-Seltzers, right? You guys ever seen those at Walmart? They're called Equate. Well, I had to get a package of those too because I only had 1 package of Alka-Seltzers and there's only 2 in there, and I need 3 because I want to test 3 different surface areas. I'm going to do 3 different trials or 3 different groups. So I've got 2 regular Alka-Seltzer tablets, and then I've got 1 that is just an Equate generic, okay? So those are the 3 that I'm going to use. And I'm going to use, notice I have a hot plate out here because I'm going to use some hot water, and I'm going to use some room temperature water, and I'm going to use some cold water, kind of like I did yesterday, you know, when we did the glow sticks. So I'm just going to heat up some water right now. I'm not going to worry about how much I'm getting at this point. I'll worry about that in a few minutes. I'll pour it into that. All right, and notice there's lots of different water that I could use, but I'm using distilled water for every one of these. So in every trial, I'm going to use distilled water, and I'm probably going to use about 250 milliliters for each one. So every single tablet, all 3 are going to get 250 milliliters of water. So that's going to be my room temperature. I've got some water heating right now, and then I'm also going to make some ice water. And I'm just going to put some ice in here. It's already kind of, oh, well, that didn't work. I don't even know if that's going to be enough. And I'm going to go ahead and get my water cold. I'm making a mess, I tell you. I really am. So I think I've got all my water. And again, I'm using distilled water for every single one of them. All 3 get distilled water. Now, we said we were going to test the surface area. So the next thing I'm going to do then is I'm going to I'm going to decide what surface areas I want to use. Now, the first surface area I'm going to use is just a whole tablet. Okay, so I'm going to use an entire tablet. And I'm not going to do anything to it. Okay, I'm just going to leave it alone. That's going to be my first trial. It's going to be my first group or my first test. Okay, my second tablet, I thought I would cut it in half. Okay, and it's kind of hard to do that. So I've got this little scalpel that I'm going to use, and what you do, I don't know if you guys have ever heard of this, it's called scoring. I'm going to scratch it, make a little like crack in it, and then I can just break it and it'll break in half. So again, I'm still going to use a whole tablet because I don't want to change the amount of Alka-Seltzer. I'm going to use one entire tablet for every test. It's just that one test is going to have the tablet whole. The other test is going to have the tablet in halves. Okay, so I'm gonna kind of scratch this. And this might not be exactly half, but it's going to be close. I probably could have done a better job of getting right in the middle, but anyway, it's going to be about half. Now notice another thing that I'm doing. Okay, so there it is. There's and it's not exactly halves, but it's close. Another thing that I'm doing is notice how I scratched that and I broke that like on top of this package. Because, I don't know if you can see this, but when I did that, little bit of powder and pieces of that Alka-Seltzer kind of came off of the tablet. And if I lost that, then this wouldn't be an entire tablet, would it? It would be less than an entire tablet. And I don't want to change the amount of Alka-Seltzer that I'm using, okay? I want to change the surface area, but I don't want to change the amount. So I made sure that I scratched it and I broke it on this package so that all of the Alka-Seltzer, I still have an entire tablet here. So I have an entire whole tablet. I have an entire tablet in half. And then my last tablet, I'm going to go ahead and use this other one just because it's already in the package. And I'm going to crush it up into small pieces, okay? So I'm still going to have an entire tablet. I'm just going to break it in tiny pieces, okay? So that's what I'm doing now. I'm just kind of crushing it up. And then I might open it up a little bit so we can see it, make sure it's crushed good. And it's pretty crushed here. Again, it's still an entire tablet. I've not changed the amount of Alka-Seltzer. I'm keeping the same amount of Alka-Seltzer for every test that I do. Okay, so now I have that tablet. Again, that's the Equate tablet. And it is crushed up pretty good. So I have one whole tablet. That's my surface area is whole. One entire tablet halved. So I still have the same amount. It's just halved. And then the last one is one entire tablet crushed. So again, the same amount, it's just crushed up. So that way, I have 3 different surface areas, okay? As I said, I'm using distilled water on every one of them. Remember, there's different kinds of water that I could use. I could use tap water. I could use bottled water. But I had some distilled water back in the back. So I'm using distilled water for every one. And I'm also going to use the same amount. Notice that I'm using a 400 milliliter beaker for every test. Every test is going to be a 400 milliliter beaker. So I'm going to use the same size beaker for each one. And I'm going to use the same kind of water, the distilled water. And I'm going to use the same amount of water. I'm using 250 for the room temperature. I'm going to use 250 mils for the cold. And I'm going to use 250 mils for the hot, which looks like it's getting pretty hot now. So I'm going to go ahead and I'll take that one off in a minute. I'm going to go ahead and do the 250 in the cold first. I'm going to go ahead and get them ready. I'm going to try not to get any ice in it, but it's not working too good. Let me try it again. Because I just want the water. I don't want the ice because I'm afraid the ice could affect it, you know. Because the other beakers don't have ice, so I don't want ice in this one either. I just want the water. Okay, so there's the 250 milliliters in that one. That's the cold water. And now I'm going to try to pour out a little bit here so that I'll have 250 in the hot because I've got a little bit too much. So there's my hot. Okay. So now I guess I need to see exactly what temperature they are. So I'll have some thermometers here, just so we can kind of see what temperatures we're dealing with here. I'm gonna go ahead and use a different thermometer for each one, just to save some time. Okay. And so my cold one, let me go ahead and do my room temperature because those will take a while to get to the right temperature. My room temperature, if I kind of roll it around here, looks like it's about 20 degrees Celsius. So it's 20. And then my cold one looks like it's about 5 degrees Celsius. So it's pretty cold, 5 degrees. And then my hot one looks like it's about 64 degrees, probably 64 degrees. Okay? So that's just making sure we've got a hot, a room temperature, and a cold. All right. So now we're actually going to do our experiment. We're going to put the entire whole Alka Seltzer in one, the halves in another, and the crushed in another. And again, I'm not going to do all three of these at the same time because I won't be able to watch them all three at the same time. So how am I going to know how fast or slow they're reacting when I put them in there? What do I need to do? How do I measure how fast or slow they're reacting? Right. I'm going to time how long it takes them to, I'm not going to say dissolve, I'm going to say disappear because this is a chemical reaction. Dissolving is not a chemical reaction. We'll learn this later on, it's physical. And we want to talk about a chemical reaction here, so we're going to say they're going to disappear. Okay? So we're going to time how long it takes them to disappear. All right? So I'm going to use my phone for that. And I'm going to go ahead and start with the cold ones. And let me find my timer. No, stopwatch. There we go. All right. So since I have the whole tablet here with the cold one, I'm just going to put the whole tablet in the cold. Okay? And then I'm going, as soon as I drop it in, I'm going to start, and then I'll stop when the tablet is disappeared. Okay? So there we go. You can kind of see it's bubbling there. It's going pretty slow, right? This might take a while. Now remember this whole one, does it have the most or the least amount of surface area? The least amount. Because again, this one doesn't have as much on the outside as these others do because these others I have opened up the inside to the outside. So they have more on the outside than this one does. So this one has the least amount of, the least amount of surface area. Even though it's the biggest tablet, it has the least amount of surface area. So we have to keep telling ourselves that so we don't get confused. Right now we're at 1 minute and 8 seconds. We're still going strong. Sometimes people want to say, well, time it until it quits bubbling. Have you ever used Alka Seltzer before? Bridget, have you ever used Alka Seltzer? No. Well, I'm glad you said time it, the time it takes it to disappear or dissolve. Because if you said till it quits bubbling, it takes it forever to quit bubbling. Okay? Like we could come back 20 minutes later and it'd probably still be bubbling a little bit because it just keeps bubbling. So once the tablet is gone, that is the best time to stop it. Right now we're at 142 and the tablet is still there. It's not gone yet, so we're just going to keep waiting. I don't know if you can see it on the camera there, but it's still bubbling. But there it is. You can see the little bubbles. But it's getting close. Oh, here it's floating up to the top now. Let's see. It's just about gone. I see some little pieces. We're over 2 minutes now. Almost gone. I would say that's probably good enough. So we've got 2 minutes and 24 seconds. And what I want to do, because all of these may not take even a full minute, what I want to do is I want to do this in seconds. So what would 2 minutes and 24 seconds be in just seconds? Okay, 1 minute and 24 seconds would be 84. But this is 2 minutes. So how many seconds would that be? 2 minutes is how many seconds? If there's 60 seconds in a minute, 2 minutes is 120, and then we need to add 24 to that. So how many would that be? 144, I think. 120 seconds plus 24 more is 144 seconds. So I might write that on there somewhere. Like I might write it on the board, and you guys can, type it somewhere if you need to. So 144 seconds was a whole tablet. And remember, that was our cold water. Okay? So I'm going to reset. Now I'm going to do the halves. And I'm going to start once I drop it in, and I'm going to stop when it's gone again. And I'm going to, this is the room temperature water, by the way. Make sure I got it all in there. That one looks like it's happening quicker, doesn't it? You can just look at the bubbles and tell they're coming up faster, right? Okay, the tablet's at the top. We can see it right up here at the top. Almost gone. Or there's 2 pieces actually, because it was cut in half. So I have to wait till both halves are bubbled away. Almost gone. Okay. So I've got 59 seconds. 59 seconds. So I'm going to write that over here too, just so we can remember. So we don't have to try to memorize it. And this was the halves. And this was in the room temperature water. Okay. So now we're going to do the hot water. And this is the one we're going to do the crushed. So I'll reset it. I'm going to put the crushed one in here. You ready? Look at those bubbles. Wow. Still a couple little pieces. 13 seconds. And this was the crushed. And this was the hot water. Okay. So now, after we have collected this information, we can analyze that information, right? So what does this tell us about the answer to our question? Again, what was our question that we were trying to answer?
How does the surface area affect the reaction rate between the Seltzer and the water?
Good. How does surface area affect the reaction rate between Alka Seltzer and water? Okay. So what does this data tell us about how surface area affects the reaction rate? Or does it tell us anything at all? It doesn't tell us anything, does it? Okay? Because I just made a big boo-boo, didn't I? That's one huge mistake that I made. What is the big mistake that I made right here? I made a big boo-boo. Why does this data not tell me anything about how the surface area affects the rate of the reaction? Okay. Was there a control group?
I said that wrong. I know what I mean to say, but I don't know how to say it.
What is wrong here with this data? We have our time, which is the rate, right? It tells us how fast the reaction went. Okay, what are crushed tabs and whole tablets? What are those? Those are the different what? What was I changing when I changed that? When I used a whole, I halved it and I crushed it. What was I changing when I did these different things to the Alka Seltzer? Surface area. So those are the different surface areas that we use. Okay, we're not actually measuring the surface area. We're just saying, okay, whole surface area, halved surface area, crushed surface area. Okay? So what are cold, room temperature, and hot? What are those? Those are different temperatures, right? Why did I do that?
To see how fast it disappeared.
Look back at your question. Did I need that to answer my question? Did I need to change you need to use different temperatures to answer my question? No. Should I have changed the temperature? Should I have even done that? No. Okay? You guys, this data doesn't tell me anything. I changed the surface area and I changed the temperature. I changed two things. So how do I know? If this one took longer because it had more surface area, or less surface area, or because it was cold? Do I know which reason why it took longer? No, I don't. Do I know why this one didn't take as long? Was it because it had more surface area, or was it because it was hot? Do I know which one? No. So, these results don't tell me anything. Because I had two what? What are both of these? I changed them. What are they?
Experiment.
Which is the variable that we change?
So you change?
Yeah, that the experimenter changes. What's the name of that variable? The independent variable. You guys, I had two independent variables here, didn't I? I changed the surface area by crushing and cutting the tablet. I also changed the temperature by heating and cooling the water. I can't do both. I have to do one or the other. Which one should I have done? If I wanted to answer the question that we had, which one of these should have been my independent? This one. This is the only thing I should have changed, the surface area. I should not have changed the temperature. I should not have done that. So if I was going to do this experiment again, how can I correct that?
The temperature all the same.
Keep the temperature all the same. Does it matter which temperature? No. If you want to do them all three in cold water, that's fine. Do it. If you want to do them all three in hot water, that's fine. If you want to do them all three in room temperature water, that's fine too. As long as you keep the temperature the same in every beaker, okay? Because I wanted to know how surface area affects the reaction. The only thing I should have changed was the surface area, nothing else. Okay? Nothing else should have changed. Any questions about that? So what was my dependent variable here? Remember, your dependent variable is what you're measuring. What was I measuring? I didn't measure the tablets. All I did was cut them. How fast it disappeared, which is the rate. Okay, so I was measuring the rate of the reaction or the time that it took the reaction to happen. Okay? And that's good, because that's what I wanted to know. I wanted to know, how does the surface area affect the rate of the reaction? So I'm going to change the surface area. I'm going to measure the rate by measuring the time. I'm going to leave everything else the same. Okay? So what was another mistake that I made? If I need to leave everything else the same, what were some things that I kept the same for every beaker? Obviously, temperature was not one, but it should have been. Okay, what about the water? The same amount of water. So that would be a what kind of variable? If I kept it the same and used the same amount in every one. What kind of variable is that? Or constant. I think on your assignment that you're completing, it's the constant variable, okay? What else did I keep the same? I use the same type of water. I use distilled water in every one, okay? What else did I keep the same?
The number of tablets.
I used one tablet in every beaker. Very good. So you could say the number of tablets or the amount of Alka-Seltzer. Because remember, I broke them on the same package and everything to make sure I had the same amount in every one. Anything else that I kept the same? The size of the beaker. I use the same size beaker in every one. Okay? Is there anything that I should have kept the same that maybe I didn't? Think about what I used in each beaker. While you're thinking about that, I'm going to go back here real quick and get something.
Niagara versus generic.
There you go. Okay? I used 2 name brand Alka-Seltzers, but one of the 3 was not. It was a different brand, wasn't it? Could that make a difference? You don't know. We don't know if it could make a difference. Do we want to find out? No. The only thing I want to find out is how surface area affects the rate of the reaction. I don't want to find out how the brand affects the rate, okay? So I need to use the same brand every time. If I don't use the same brand, then it's not going to work, okay? So what we just found out here is how to do an experiment incorrectly, okay? Now, there are some things that I did right, but there's some things that I did wrong, too. So we're going to try again. Hopefully we'll have time without all the mistakes. I'm going to rinse out all my beakers. Try to get them as clean as possible. They probably aren't as clean as they could be, but I'm going to try the same thing again. Hopefully I won't make as big of a mess this time. Oh, I don't want to heat it up. I forgot. You guys tell me not to do that. We don't want to heat it up. Let's just do it room temperature because that'll be quicker. We don't want to change the temperature. I'm going to still use 250 milliliters of distilled water in every single one. I'm going to use the same size beaker. I'm not going to change the temperature. I'm going to use the same temperature in all of them. I'm not going to change the brand of Alka-Seltzer. I'm going to use the same brand every time, the name brand Alka-Seltzer, because I don't want that to be a factor affecting my results. Okay, so there is my whole Alka-Seltzer tablet. Okay, I'm still going to do a half. And then I'm going to open up one more and take this one out. Do it fresh. I'm going to go ahead and crush this one up since it's in the package already. Okay, making sure to keep this an entire Alka-Seltzer, the same amount of Alka-Seltzer in every one. Okay, let me get my little thing here and do a little bit of scratching on it. to get this one in half. Again, I'm going to keep it on the paper so that I get the same amount in every one of them. I don't want to lose any. Okay. Do I need the thermometers this time? No, I don't, because I'm not changing temperature because I shouldn't have changed it to begin with. Okay. Now, am I ready, I think? I am. Okay, so we're going to do the same thing again. Measure the time it takes it to disappear. Okay, so let's do the whole one first. Okay. Now notice that whole one in the room temperature water is going a little bit faster than it did in the cold water, but that's okay. We expect it to, don't we? Because warmer temperatures make reactions happen faster. Okay, so that warm temperature, that room temperature is warmer than cold was. So it's probably going to be less than 144 seconds. It's down there. Okay, it just floated up to the top. You can see it right there. It's not going yet. Almost, but not yet. Okay, so that's 59 seconds. So now, we're doing, that's not an independent variable anymore. Room temperature for all of them. All are going to be room temperature. Because that's just easier for us to do. So 59 seconds, is that what I said? 59 for the whole. Okay. Room temperature again, but this time we're going to do the halves. Let me reset this. Okay. Move this out of the way. Move this over where you can see it better. They're at the bottom right now. Okay, now they're floating, or one of them is. Oh, there comes the other one. Okay, 53 seconds. For the halves. Okay, now we'll do, again, room temperature, we'll do the crushed. There comes one piece to the top. Still a few pieces at the bottom. Oh, there comes another. There comes some more at the top. There comes the other one to the top. Yep, they're all at the top now. Okay, 51 seconds for the crushed. Okay. So now we kept the amount of Alka Seltzer the same, the brand, the temperature the same, the size of the beaker, the kind of water, the amount of water the same. Those are all the things we kept the same. The only thing that we changed, that I changed between each test, was the surface area of the Alka Seltzer. Okay? And then I measured the time. So now, can we come to a conclusion by analyzing this data? Yes. Okay, so what conclusion can we come to about how surface area affects the rate of reaction between Alka-Seltzer and water? The bigger the surface area, the faster the reaction, because we know that that crushed tablet has a bigger surface area. So it has, so we see it went 51 seconds, which was faster, okay? On the other hand, the whole tablet had a smaller surface area, and it took more time, which means if it took more time, it went slower, didn't it? Okay? And again, that's something else that students, they see that big number and they're like, oh, it's faster. But remember, more time means it was slower, right? Because if it takes you 10 minutes to get to school versus 5 minutes to get to school, you were driving slower when it took you 10 minutes, right? You were driving faster when it only took you 5 minutes. So less time means faster and more time means slower, okay? So any questions about this little experiment that we did, how to do it, what we did wrong, and how to make it right? Any questions? Okay. So then that's all I have. So you should pretty much have your assignment done then, right?